So we need to find 4 second-order partial derivatives of the given function. Let's start by finding the first-order partial derivatives, which we need to find the second-order partial derivatives. So zx, so the first-order partial derivative with respect to x equals 3y times 7 times e to the power of 7x. So this equals 21y times e to the power of 7x. Now let's find the first partial derivative with respect to y. So zy equals e to the power of 7x, because here we treat x as a constant, so it's e to the power of 7x times 3, so it's just 3e to the power of 7x. Well, now let's find the second order partial derivatives. So we will start by finding the zxx. So this is basically the derivative of zx with respect to x. So we need to differentiate this expression. And here again we treat y as a constant, so it's 21y times, now we will use the chain rule to find the derivative of e to the power of 7x, so times 7 times e to the power of 7x. So this equals 147y e to the power of 7x. Now let's find zyy. So we need to differentiate the first order partial derivative of z with respect to y, with respect to y again. So we differentiate this expression with respect to y, and since we treat x as a constant, so this equals the derivative of 3e to the power of 7x with respect to y. So it's just the derivative of a constant with respect to y, so it's 0. Well, now let's find zyx. It equals 3 times 7 times e to the power of 7x, so it's 21 times e to the power of 7x. And we know that zxy equals zyx, and it also equals 21 times e to the power of 7x. So we have found all 4 second order partial derivatives of the given function.